There is a confusion at the center of the modern conversation about extraterrestrial life that has quietly poisoned the well of serious scientific inquiry for decades. It is a confusion so pervasive, so thoroughly baked into popular culture, that most people never stop to examine it. And the confusion is this: people assume that if you reject the idea of alien visitors, you must be rejecting the idea of alien life. Those two positions are not the same thing. They are not even close to the same thing. One is a statement about the biological richness of the cosmos. The other is a statement about the brutal, unforgiving, and largely unappreciated physics of interstellar travel. Smart people, analytically rigorous people, do not dismiss extraterrestrial life. What they dismiss is the assumption that another civilization has already found us, is hovering invisibly above our cities, and has somehow figured out how to violate the fundamental laws of thermodynamics while doing it. Let us begin at the beginning, with the universe itself. Modern astrophysics has arrived at a fairly settled position on the question of cosmic habitability. The Milky Way galaxy alone contains somewhere between 200 billion and 400 billion stars. A substantial fraction of those stars host planetary systems. A meaningful fraction of those planetary systems contain worlds that sit within the liquid water zone, that narrow orbital band where the chemistry of life as we understand it becomes plausible. When you do the mathematics carefully, even with conservative assumptions, the number of worlds where biology could have ignited is enormous. Life, at least in its most primitive microbial form, is almost certainly not rare. The ingredients are common. The chemistry is replicable. The physical conditions required are not unique to Earth. So the scientific community is not having an argument about whether life exists elsewhere. That argument is largely settled in the probabilistic sense. The argument is about a different and far more subtle question, which is whether two technological civilizations, meaning civilizations capable of building machines and communicating across space, could ever overlap in time and geography within a galaxy the size of the Milky Way. And this is where the mathematics becomes deeply humbling. Imagine a massive pitch-black football stadium completely devoid of people sitting in total silence. Over the course of one entire year, 2 solitary fireflies are permitted to enter that stadium. Each firefly lives for only a single fleeting minute before fading away into the dark. Now consider the probability. What is the mathematical probability that those 2 solitary insects will choose the identically same minute out of an entire year to enter that stadium and also happen to fly into the identically same corner of the massive field to find each other? The probability is not small. It is not negligible. It is fundamentally 0. And this analogy is not decorative. It is the actual structure of the problem we're describing. The stadium represents the massive geometry of the Milky Way galaxy, 100,000 light-years across, containing hundreds of billions of stellar systems spread across a 3-dimensional disk of almost incomprehensible scale. The single year represents the 14-billion-year history of the cosmos, from the first atomic nuclei condensing out of the primordial plasma all the way to the present moment. The 2 fireflies represent 2 independent technological civilizations. The minute each firefly lives represents the brief window during which a civilization is technologically active before collapsing from internal thermodynamics, resource exhaustion, or the simple entropic mathematics of complex systems. We are not isolated merely by vast physical space. We are isolated by the crushing weight of deep time. Consider the timeline more carefully. The universe is approximately 13.8 billion years old. Our sun formed roughly 4.6 billion years ago. Technological civilization on Earth, meaning the narrow window during which we have been capable of transmitting electromagnetic signals into space, is approximately 100 years old. 100 years out of 13.8 billion. If you compress the entire history of the cosmos into a single calendar year, human technological civilization occupies the final 2 milliseconds of December 31st. The probability that another civilization somewhere in a galaxy of hundreds of billions of stars reached its own brief technological window during those same 2 milliseconds of cosmic time is not a matter of pessimism, it is a matter of combinatorics. Serious scientists do not reject aliens. They reject the assumption of synchronization. They reject the deeply human tendency to place ourselves at the center of the cosmic timeline, to assume that because we are broadcasting right now, some other civilization must also be broadcasting right now, and must also be close enough to detect our signal and respond within a human lifetime. The universe does not organize itself around human convenience, but let us suppose, for the sake of analytical rigor, that we were wrong about this. Let us suppose that the temporal alignment problem somehow resolves itself. Let us suppose that an advanced civilization does exist contemporaneously with us, and that it has managed to develop spacecraft capable of crossing the interstellar void. This is where the physics becomes not just challenging, but categorically brutal. To travel from the nearest star system to our own, a journey of approximately 4 light years, in any reasonable fraction of a human lifetime, a spacecraft must accelerate to a significant fraction of the speed of light. Let us say 10% of light speed as a conservative estimate for a truly advanced civilization. To push even a modest spacecraft carrying biological passengers to 10% of light speed requires an energy output that is not simply large, but astronomically large in the most literal sense. The mathematics works out to roughly the total annual energy output of our entire sun. To decelerate upon arrival, you spend that energy again. To return home, you spend it twice more. And here is where thermodynamics enters the conversation with complete and unapologetic authority. The second law of thermodynamics is not a guideline. It is not a suggestion that advanced civilizations might find ways around with sufficiently clever engineering. It is a fundamental constraint woven into the mathematical structure of physical reality. When you convert energy into work, you produce waste heat. You cannot avoid it. You cannot contain it. You cannot cloak it with any technology that is consistent with the known laws of physics. Any spacecraft generating the power equivalent to a small star is radiating an absolutely staggering thermal signature in every direction around it. If such a vessel entered the Earth atmosphere, the physical consequences would not be subtle. The localized thermal radiation would be so intense that it would saturate every infrared satellite currently in Earth orbit. It would produce atmospheric heating on a scale visible from ground-based optical telescopes. It would create ionization effects in the upper atmosphere detectable by every radio telescope array on the planet. The notion that such a vessel could hover silently above populated areas, invisible to the dense electromagnetic monitoring infrastructure of a modern technological civilization, is not merely implausible. It is a direct contradiction of the thermodynamic laws that govern all energy conversion in the universe. Stealth at interstellar energy levels is a mathematical impossibility, not a technical challenge, not a barrier awaiting a clever engineering solution. A mathematical impossibility. The same laws that make it impossible to build a perfectly efficient heat engine also make it impossible for an interstellar spacecraft to operate without radiating enormous amounts of detectable energy. These are not two separate laws. They are the same law. And yet the popular imagination continues to produce images of metallic saucers gliding silently through overcast skies, leaving no heat signature, generating no atmospheric disturbance, undetected by the most sensitive instruments humanity has ever constructed. This is not science fiction operating at the edge of the plausible. This is science fiction operating in direct contradiction to the most thoroughly tested physical laws we possess. There is a third layer to this argument, one that receives far less attention than the temporal isolation problem and the thermodynamic stealth paradox, but which is perhaps the most devastating of all. It concerns the fundamental absurdity of biological interstellar travel. Consider what a biological organism actually is. It is a fragile, water-based chemical system operating within an extraordinarily narrow band of temperature, pressure, radiation, and gravitational conditions. The human body is approximately 60% liquid water. It requires a continuous supply of oxygen, specific nutrients, regulated temperature, and protection from ionizing radiation. It ages. It gets sick. It requires sleep. It is, by almost any objective engineering standard, an extraordinarily poor vehicle for long-duration space travel. The interstellar void is not merely inhospitable to biological life. It is one of the most comprehensively lethal environments in the known universe. The temperatures approach absolute zero. The radiation environment includes high-energy cosmic rays capable of penetrating most known shielding materials and directly damaging DNA with remarkable efficiency. The journey durations, even at significant fractions of light speed, span decades or centuries, and the gravitational and inertial forces required to accelerate and decelerate a biological body to and from interstellar velocities would need to be managed with extraordinary precision to avoid catastrophic physiological damage. Any civilization advanced enough to solve the energy problem to actually generate and channel stellar-scale power outputs would necessarily be a civilization that had already developed computational and nanotechnological capabilities far beyond anything we can currently imagine, and a civilization with those capabilities would have absolutely no rational reason to send biological bodies across the interstellar void. None. The efficient solution, the solution that any analytically rigorous technological civilization would arrive at, is to send information, send microscopic self-replicating probes small enough to accelerate cheaply, capable of manufacturing everything they need upon arrival from local materials, or send compressed mathematical data streams carrying the full informational description of the civilization, its science, its history, its accumulated knowledge, traveling at the speed of light itself. Seeing a physical biological creature, recognizable as a biological creature, stepping out of a metallic craft and interacting with humans is not evidence of an advanced civilization. It is evidence of a civilization no more advanced than our own, still trapped inside fragile biological bodies, still hauling liquid water and organic chemistry across a universe that is profoundly indifferent to the survival of either. The logical progression of advanced physics and advanced computing does not lead toward biological ambassadors in metallic ships. It leads away from biology entirely, toward forms of intelligence and exploration that are so far removed from our current biological frame of reference that we would very likely not recognize them as intelligence at all. This is the picture that emerges when you follow the physics honestly and without the distorting lens of human-centered narrative. The universe is almost certainly not empty. The mathematical probability that we are the only information processing system in a galaxy of hundreds of billions of stars, in a cosmos of hundreds of billions of galaxies, is genuinely negligible. The universe has had 14 billion years to generate complexity, and the chemistry of life is not particularly exotic. Life almost certainly exists elsewhere. But the same universe that almost certainly harbors other life also enforces its vast distances through the strict and impersonal machinery of thermodynamics and temporal geometry. The energy barriers are not obstacles waiting for sufficiently determined engineers. They are structural features of physical reality. The temporal barriers are not unfortunate coincidences. They are the inevitable consequence of how briefly complex information processing systems tend to persist against the long grinding entropy of deep time. When we look up at the night sky, at those faint points of light scattered across the darkness, we are looking at a universe that is simultaneously full of potential and protected by the most elegant and impenetrable barriers that physics has ever produced. The distances are not merely large. They are large in a way that interacts with time and energy in ways that make crossing them, in the form of biological visitors with physical ships, not merely difficult, but fundamentally inconsistent with the laws that govern all known physical processes. Smart people understand this. They understand that the absence of alien visitors is not evidence of an empty universe. It is evidence of a universe that takes its physics seriously. The dark ocean between the stars is not a mystery waiting to be unraveled by the next declassified government document. It is a physical structure as real and as mathematically well-defined as the curvature of space-time around a massive object or the quantization of energy at the atomic scale. We are not alone in the cosmos. We are simply alone in the way that only the deepest physics of an ancient universe could arrange.